Okay, in this video we're going to go over target 2, which is transforming quadratic functions. Before we use the flippable that I printed out for you guys, I need you to get out a sheet of paper and you're going to copy down either on that sheet of paper and put it in your binder or copy it down into your notebook, this graphing functions vocabulary. This vocabulary is very important for helping you answer questions later on in the unit. So the first vocab word is axis of symmetry. So when we have a quadratic function, okay, the standard form is ax squared plus bx plus c. The vertical line that goes through the middle of that graph, so the vertical line that goes through the vertex in the middle of the parabola, is found using the equation x equals negative b over 2a, and that's called the axis of symmetry. You should recognize that formula, negative b over 2a, because that's also the formula you use to find the vertex of a quadratic function. Remember, that gives us the x coordinate for the vertex. Next vocab word is vertex. So the vertex is the point where the graph of the quadratic function intersects the axis of symmetry. The vertex is going to be either the highest point of the parabola if it opens down, or the lowest point of the parabola if it opens up. Last vocab you need to know is end behavior of a graph, because you will see questions on the EOC and on your exams where it asks you to describe the end behavior. So the end behavior is just basically telling me, does it have a minimum or a maximum? And you're going to tell me moving to the left or to the right if it's increasing or decreasing. So if you guys are still writing that vocab, which I'm sure you are, go ahead and just pause the video. And when we hit play, we're going to move on and start using that foldable. Okay, so reflecting across the x-axis. So to cause a reflection across the x-axis, we're going to change our a value. So if we want our graph to flip down, we're going to go from a positive a to a negative a. Or if we want to flip it up, we're going to do vice versa. We're going to switch it from a negative a value to a positive a value. If you're still writing, just go ahead and pause the video. And then we're going to move on and talk about vertical compressions. So to vertically compress our graph, okay, which is actually making it wider, we are changing the a value again, but this time we're making it smaller. So in my example, the a value is 1 because there's nothing in front of x squared. So to make it smaller than 1, I'm going to have to use a fraction. So I used 1/2, but 3/4 or 2/3, anything smaller than 1 would cause a vertical compression, which is making the graph wider. Keep in mind, I still want it to be a positive number though, because if it was negative, that would cause a reflection. I'm not trying to reflect it, I'm just trying to make the graph wider. If our original was something like 2x squared, changing it to just x squared or 1x squared would also make it wider or make a vertical compression. So if you're still writing, go ahead and pause the video. And then we're going to talk about vertical stretch. Okay, so for a vertical stretch, we're changing a again, but this time we're making it a larger number, which is going to cause my graph to be more narrow. So my original, my a value is 1, since it's just x squared. So if I wanted to make my graph more narrow or make a vertical stretch, I would change it to 2x squared or 3x squared or 4x squared, any number larger than 1. If my original graph was something like 2x squared, then I'd have to pick a number bigger than 2. So like 3x squared, 4x squared, 5x squared. If you're still writing, just pause the video. Then we are going to talk about translations. Okay, for translating, we're going to be changing our C value. Okay, we're not changing A anymore, now we're changing C. So when we change our C value, if I want to move my graph down, okay, I would pick a number smaller than what I started with. So in my original, there is no C there, so that means it's 0. So anything smaller than 0 is going to make the graph go down. So that's why when I change it to -5, that caused it to go down 5 units. Okay. Keep in mind also that's changing the vertex. So my original vertex was 0, 0. Now my vertex is 0, -5. If you're still writing, pause the video. And then the last thing we're going to talk about is translating up. Okay, so just like with translating down, we're changing the C value. This time though, we're making our C value larger. So if I wanted to translate my function up 5 units from 0, I would do +5, and that would cause it to go up 5. Okay, if you guys have any questions about these notes, or if you need any more help, don't forget you can message me on Schoology or Remind. And of course, you can always come back later and watch this video again.